in the calendar, no?
Yes.
Mm. Mm.
I will try and tell him, sir.
Yes, as I said, if you miss a few lectures, especially the initial ones, then you are handicapped, no? There is a note uploaded, but reading the note, I don't think you can get the essence of the subject. So after you know the subject, then you can read the notes and yes. Uh, what is your suggestion? How many students are there now? Let me check. About 26 students are there. 26 students are there. 27. Yes, today's one is also updated incorrectly. It is from 11 to 12. 29. Okay. Okay, we shall start. Okay. Shall I do the lecture? Yes. Okay. So let us. Yes, some are saying many students went home because the timetable was not updated till Friday. So same question, problems will be there for tomorrow's lecture also. Mm, okay, we shall now it's already 11:10 or 50 minutes left. We shall do the lecture. Okay, and for students who are not here, now let us do something for them later. Yes. As I said earlier, let me find the recording button here. Yes.
Recording in progress.
Okay, students, this is the intermediate calculus course. And as I told you earlier, attendance is extremely important. So don't intend to miss a lecture unless there is a valid reason for it. Because things are really progressive. They build on the knowledge of the previous lectures. Therefore, if you miss a lecture, although the note is there in the LMS, you might not be able to follow the rest of the lectures for a while. So attendance is extremely important. Okay. Don't know how many are registered. It's much more than 32 students who are present, but since you are there, I will continue. I will do the lecture, and maybe for tomorrow's lecture, which is held from 3 to 6. Okay, physical. So please send the message to your friends also. It should be updated by tomorrow, I think. So first chapter of the course is on sequences. So we will be studying the definition of a sequence. What is a sequence? Then formula for the nth term of a sequence, limits of a sequence, limit of a sequence, convergence, divergence, limit laws, monotonic sequences, and bounded sequences. So to understand most of them, you need to know the definition of a sequence. What do we mean by a sequence? So chapter 1 is on sequences. Chapter 1 is on sequences. So what is a sequence? A sequence is a list of numbers. It's a list of numbers written in a definite order. Something like, say, 2, 4, 6, 8, ... This is a sequence, list of numbers. 2, 4, 6, 8, ... The nth one, we can say 2n. This is an example of a sequence. A sequence is a list of numbers, a list of numbers written in a definite order. Written in a definite order. So here, after you list the numbers, this one is called obviously the first term, second term, third term, fourth term, and ... to denote the continuation, 2n. This is the nth term of the sequence. So that is the rough definition of a sequence. For example, 1, half, 1/3, 1 over n, comma, ... This is an example of a sequence. First term here is 2. First term of the sequence. Here the first term is 1. second term is half, third term is 1/3, nth term is 1 over n. So that is basically what a sequence is. A list of numbers written in a definite order. So to make it mathematically precise, okay, can you understand what I say? You all hear me, no?
Yes, sir.
Okay. To make it mathematically precise, we give the definition of a sequence, a sequence of real numbers, a sequence of real numbers is a real valued, I'll tell you what that is, okay? Real valued function. You learn about functions a lot now. Functions, a real valued function is a real valued function whose domain is the set of all positive integers. Set of all positive integers. Sorry. A sequence of real numbers is a real valued functions. Meaning, when we say sequence of is a real valued function, functions have input, output, both. So here the inputs are coming from whose domain? Domain is the collection of all inputs for a function. So the whose domain is the set of all positive integers. The set of all positive integers is 1, 2, 3, ... That is the set of all positive integers. A-level combined maths students used Z plus for positive integers, and we also use n natural numbers. They are the same, okay? So the set of all positive integers is the domain. So earlier we said sequence is just a list of numbers written in a definite order. So there are lots of undefined terms there. That is why we are going to go for a precise mathematical definition of a sequence. A sequence of real numbers, meaning outputs are real numbers, is a real valued function whose domain is the set of all positive integers. Look at the first list that we gave for an example of the sequence 2, 4, 6, 8, 2, 8. So what do we mean by that list? Now we are saying a sequence is a function whose domain is the set of all positive integers. Here, when you look at this sequence, okay, nth term is 2n. So if you say function f from Z plus to r, real valued function, meaning values assumed are real numbers. Outputs are real numbers. Outputs are real numbers. Inputs are positive inputs are positive integers. All positive integers. Inputs are positive integers. Input. So a sequence is a function, let us say f from z plus, meaning positive integers to real numbers. Outputs are real numbers. For example, f of n given by f of n equals 2n. Now f of n, now n is what? N is inputs are positive integers now. So n can take on values 1, 2, 3, 4 and so on. F of n output is given to be 2 times the input. So when you put n equals 1, n equals 1, we get 2. When you put n equals 2, n equals 2, 2 times 2, that is 4, n equals 3, 6, and you can generate the numbers given in the first example as a sequence, as a list of numbers through this function formulation. So a sequence of real numbers. Now its outputs are real numbers. It's a real valued values obtained by the function are real numbers. Need not be positive integers. Here for this example, f of n equals 2n, values happen to be integers. There is no such requirement. Outputs are real numbers, inputs are positive integers. So hereafter, we shall not use this function notation. Okay, instead of f of n, so for every sequence, domain is the set of 4 positive integers. Domain doesn't change. Okay, so it is 1, 2, 3, 4, and so on. We said no, list with a definite order. The order is coming from the order of the positive integers. 1, 2, 3, so on. So here for the example given by f of n equals 2 to the n, okay, that can be written this way also. Just listing the outputs. First output, second, third, and so on. So hereafter, rather than using f of n, okay, f of n, we shall use f of n equals a subscript. යටින් තියන්නේ. So we shall use f of n equals an for n belongs to z plus positive integers, and the sequence given by this, given by this shall be denoted by then make it then f වලින් අපේ ෆන්ක්ෂන් එකෙන් n කියන එක n කියන පොසිටිව් ඉන්ටිජර් එක මැප් කරන්නේ an කියන තමයි අපි denote කරන්න යන්නේ. So the sequence given by this shall be denoted by මෙහෙම. Denoted by bracket එකක් දාලා an. එතකොට අර අපේ first sequence එක that is 2n. 2n කියන sequence එක මොකද්ද? 2 n කියන sequence එක we will if we write the terms when n equals 1 it is 2, n equals 2 it is 4, n equals 3 6 and dot 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 on that. So the sequences are hereafter not written using f of n notation, they are written using just an bracket parenthesis is the notation that we use for a sequence. A1, so when you take an sequence, we write an is A1, A2, A3, dot dot dot. Here an, nth one, dot dot dot. It continues. This list is what we call a sequence. A1 is called the first term, first term of the sequence. This one is the second term, and third term. Here, this is the an is the nth term of the sequence, nth term of the sequence. So let us now look at a few examples of sequences to see whether you understood what I said. These are some examples of sequences. 1, 4, 7. Actually, an open parenthesis should be there, and then closed parenthesis should be there. This is just the very beginning. Now, before we talked about a sequence being a function, we just said it's a list of numbers written in a definite order. So 1, 4, 7, 10. This is a list of numbers. This is a list of numbers. 1 half, 1/3, 1/4, 1/4, 1/9, 1/16, 1/25. It's a list of numbers. It doesn't stop, okay? It continues. So definition is a sequence of real numbers. Now they are using this notation straight away, but I did not use it. Is a function from the positive integers, meaning inputs are positive integers to real numbers are. Real numbers, outputs are real numbers. For each positive integer integral index n, the output an is called the nth term of the sequence. That's what I explained earlier. So the sequence, now what is the notation for a sequence? A1, A2, A3. This list of numbers is denoted by parenthesis an. So in the function notation here, so that part. Now, graphing a sequence. How do you graph a function? Now, sequences are functions, no? Sequence is a function whose domain is the positive integers. So, if you are now, let us try to graph our first example, graph of a function. Graph of I said function sequence. Graph of a sequence. When you try to draw the graph of a function, what do we plot? We plot in the xy plane input, comma, output. The set a collection of points. Input, comma, output. Input is on the x-axis. Output is on the y-axis. Graph of a sequence. So yeah, it is the same as now when you go to sequences. Inputs are n's. N going from 1, 2, 3 and so on. Outputs an. So if you want to graph of a sequence, what do? You plot the points n comma an. N comma an. So the next example, sketch the graph of the sequence. Sketch the graph of the sequence 2n. That is a sequence. No? Sequence. So, what are the values that n can take on? N can take on 1, 2, 3, and so on. So you can generate this list of points. N. So how do you sketch the graph of the sequence 2n? So n. This is the an axis. X-axis becomes the n. N. This is 0, 1, 2, 3, 4, and so on. F. When n equals 1, when n equals 1, A1. 1, A1. A1 is now for this particular sequence, AN. Nth term is 2 to the n. So what is A1? A1 is equal to 2. 1 n equals 1, so 2 times 1, 2. A2 is equal to 4. A3 is equal to 6. Now if I plot those pairs, 1, comma A1, 1, comma A1, 1, 2. 1, comma A1 is this point, just that dot. That is a point on the graph. And there is nothing between 0 to 1 because my domain consists of 1, 2, 3, 4, 5 and so on. Positive integers only. So no curves. It's a bunch of dots. It's a bunch of dots. Wait. I draw it can when a call comes that happens. Students wait there. So to plot the graph of, now you all can see, no? Students, you can see the screen. So we are going to sketch the graph of the sequence 2n. 2n. So we said input, output. That is what we sketch when we sketch the graph of a function. Input versus output points. So for the functions that you have considered, they are generally curves. But here you don't get curves, you get a bunch of points because your domain is the set of all positive integers. Domain is the set of all positive integers. So when n is equal to 1, yeah, this is 1 comma 2 point. 1a1. Then put 2. Put 2, it's 4. 2 comma 4. Then put n equals 3. 6. So the graph of the function is these dots, and the dots continue as n gets bigger and bigger. So that is the graph of the sequence given by 2n. Is that clear to you? How to draw the graph of a sequence? So say sequence is given using this notation. Parenthesis 2n මෙහෙම බ්‍රැකට් එකයි 2n කියලා ලියුවාම මේක තමයි සීක්වන්ස් එකට නොටේෂන් එක. සීක්වන්ස් එකක් කියන්නේ මොකද්ද? සීක්වන්ස් එකක් කියන්නේ ෆන්ක්ෂන් එකක් ඩොමේන් එක පොසිටිව් ඉන්ටිජර්ස් වෙච්ච. ඩොමේන් එක පොසිටිව් ඉන්ටිජර්ස් වෙච්ච ෆන්ක්ෂන් එකක්. ඒතකොට graph එක අඳින්න කිව්වොත් එහෙම ෆන්ක්ෂන් එක අපි කරන්නේ input, output relation a points තමයි xy plane එකේ මේ අපි plot කරන්නේ. X axis එකේ inputs දාන්නේ, y axis එකේ outputs දාන්නේ. එතකොට දැන් මෙතෙන්දී since the domain is the positive integers, there is nothing between 1 and 2 in the domain. 1 2 අතරේ මොකුත්ම නැහැ domain එකේ. positive integers නැහැනේ මේ දෙක අතරේ. එතකොට මේක තමයි මේ graph එක වෙන්නේ a function එකේ. හරි? එතකොට අපි තව දැන් graph ටිකක් ගමු. Next example, sketch the graph of of the sequence sequence 1 over n. Sketch the graph of this sequence 1 over n. Then මොකද කරන්න ඕනේ? We have to put values for n. මේ sequence එකේ graph එක අඳින්න කිව්වහම අපි අඳින්න ඕනේ මොකද්ද? n, an. n, an pairs තමයි අඳින්න ඕනේ. We have to plot the pairs n, an. So sequence is 1 over n. So our an here is given to be 1 over n. So for n equals 1, a1 equals 1 over 1. That is 1. For n equals 2, a2 is equal to 1 over 2. If you put n equals 2, it is 1 over 2. n equals 3, then what? a3 is 1 over 3. ඒ විදිහට තමයි යන්නේ. 1, a1 අඳින්න ඕනේ. 2, a2, 3, a3. ඒ විදිහට අඳින්න ඕනේ. So sketch the graph of that sequence 1 over n. Your graph is going to look like n axis 2, 3, 4, 5, 6, and so on. Here 1, 1. That is 1, 1 point. Here 2, 2, half. 3, 3, 1 third. So 2, 1, 1, 2, half. Half is here. Then 3, 1 third, 1 third, 1 third. Here 1 over 2, 1 third. Here. So 1/4, even closer, 1/5, even closer, and you see a bunch of dots. They are getting closer and closer to the x-axis or the n-axis. 1/n. 1/n. Then let us sketch the graph of the sequence. Say 2. One over 3. Yes, very good. Next example, sketch the graph of this sequence 2. Now what is an? We said graphs, sequences are denoted by this notation, an. What does that mean? It is a function whose domain is positive integers and whose range consists of real numbers, an. So here an is 2. An is 2. So what is a1? a1 is 2. a2, again, an is 2, no n there. So a2 is also 2. a3 is also 2, and so on. That continues. So when you plot the points, 0, we need 1, 2, 3, 4, 5, so on. 1 comma a1. 1 comma a1 is 2. So there. 2 comma again a2 is also 2. a3 is also 2. This is 2. This is 2, and so on. Here these dots are getting closer and closer to the x-axis as n gets bigger and bigger. Here, no matter how big n becomes, the values an, they remain at 2. So that is the graph of the sequence 2. Then let us look at another sequence, different looking one. -1 to the n sequence. Graph this sequence, -1 to the n sequence. So what is your an? An is what's inside the parenthesis now? -1 to the power n. So when n is 1, this is -1 to the power 1. That is equal to minus 1. a2 -1 to the power 2. That is -1 times -1. That is +1. a2. a3 would be -1 to the 3. -1 to the power 3, which is equal to -1 multiplied odd number of times, -1. a4 is -1 to the power 4, that is +1. This multiplied by another minus sign. So it keeps on changing, -1, +1, -1, +1, and so on. So how do you draw the graph of this function? If you draw the graph of the function, this is for an, this is for n. 1, 2, 3, 4, 5, A1. When you put n equals 1, you get minus 1. So 1 comma minus 1 here. 1 comma minus 1, a dot here. Then 2 comma plus 1. 2 comma plus 1, a dot there. Then when n equals 3, again minus 1. N equals 3, this is the n axis, no? N equals 3, it is minus 1. Minus 1. N equals 4, A4 is plus 1. A5 is going to be minus 1. So, dots, see, no matter how far you move along the n-axis, these values are not settling. It's minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1. So, no matter how large n becomes, that behavior will remain. So, now let us look at the examples that we did so far. I have some chats, let us see. So, just a line, minus 1, plus 1. Yes, minus 1, plus 1. Yes, very good. Yes. Now, let us see what's there in the note. So, graph the sequence an equals 2n. The graph of a sequence an is the graph of the points n comma an. For n going from 1, 2, 3 and so on. So, we did that for 2n. And then there are different notations given for sequences. Different notations are given for sequences. 1 over n plus 1 sequence can be written as an equals 1 over n plus 1. An is 1 over n plus 1, n going from 1, 2, 3 and so on. Or just list the numbers. List the numbers, half, 1/3, 1/4, because when you put n equals 1, it is half. N equals 2, it's 1 over 2 plus 1, 1 over 3. When we put n equals 3, it's 1 over 4, 1 over 5. So, nth one is 1 over n plus 1. This notation is also accepted for sequences. And this is square root of n minus 2. Square root of n minus 2. Now, here, if you put n equals 1, it becomes a square root of a negative number. Square root of a negative number is not a real number. Okay, negative 1. Negative 1, square root of negative 1 is I, it's a complex number. So, we are considering only real valued sequences. Therefore, here, if I write it like this, then my n should not begin with 1. That's a minor point. So, now this sequence is a sequence which runs from 2, 3, 4 and so on. So, you might say it's not a function defined on the positive real numbers. It's 1 is a positive real number. It's not defined for that. True, but this type of sequences are also can be considered. Missing a few positive integers in the definition. So here 0, 1, this. Here n, this is the first term is 0 because n equals 1 is not a real number. When n is equal to 2, we get the first real number, 0. When equals 3, 3 minus 1 square root is square root 1, that is 1. When n equals 3, 3 minus 2 is 1. Yes. When n equals 4 minus 2, that is square root of 4 minus 2 is square root 2, square root 3 and so on. So that's a minor thing. Don't get confused with that. Sequence doesn't have to start at 0 is the comment given, taking the second example into account. But that's a minor thing. These different notations are used to denote sequences. Yes. Can you do the first one? List the first 4 terms of the sequence 4 over 2n plus 5. First 4 terms. What is the first term? N equals 1. So 4 over, if you put n equals 1, yes, 4 over 7. 4 over 7, good. Good. So first term is 4 over 7. Second term, put n equals 2. So 4 plus 5 is 9. 4 over 9. Third term, put n equals 3. 4 over, if n is 3, this is 6 plus 5 is 11. 4 over 11. And for first 4 terms, put n equals 4. 8 plus 5 is 13. 4 over 13. Those are the first 4 terms of the sequence given by 4 over 2n plus 5 parentheses. So you can similarly do questions 2 and 3. 4 over 9, yes, 15 over 9. Yes, for the second one, half, 2 over 5, 3 over 10, 4 over 17. So let's see. This one, first term, n equals 1. 1 over 1 squared plus 1. 1 over 1 squared plus 1. 1 squared plus 1 is 1 squared is 1 plus 1 is 2. 1 over 2. Second term, 2 over 2 squared plus 1. 2 squared is 4. 4 plus 1 is 5. 2 over 5. 3 over, this is 3 squared. 9 plus 1, 10. 3 over 10. Fourth term, 4 over, n is 4 now. 4 over 4 squared, 16 plus 1, 17. Yes. Minus 1. Yes. List the first 4 terms of the sequence. 5. This is 4. This you can do now. Minus 1 to the n. When you put 1, it is minus 1 to the power 1 over 1. So minus 1 to the power 1 over 1. That is what? Minus 1 to the minus 1. Yes. What are the first 4 terms of this sequence? N equals 1. N equals 1. We get minus 1 to the 1 over 1. N equals 2. Minus 1 to the 2 over 2. N is 2. N equals 3. Minus 1 to the 3 over 3. N equals 4. minus 1 to the 4 over 4. N equals 4. Minus 1 to the power 1 is minus 1 over 1 is minus 1. This is minus 1. Minus 1 squared. Minus 1 times minus 1 minus times minus is plus, no, plus 1. Plus 1 over 2. This is minus 1 squared is plus 1. So minus 1 cubed must be minus 1. Minus 1 over 3 minus 1 to the even power is plus 1 divided by 4. So those are the first 4 terms of the sequence given by that. Yes. Now, find the formula for a general term, an of the sequence. 1 over 5, 1 over 25, second term. Third term, 1 over 125. 1 over 165 dot dot dot. Find a formula. One formula that fits into this is, so they are asking us to write an. Find a formula for the general term an. An is the nth term. No? Yes. One over, yes, very good. So, what would it be? 1 over 5, they have used the set bracket. It's better if we have parentheses. 1 over 5, 1 over 25 is 1 over 5 squared. No? 1 over 125 is 1 over 5 cubed. 1 over 625. So these are, yes. What is a good an for this? Good an for this? An should be 1 over 5 to the power n. An equals, this is 4, n going from 1, 2, 3, dot, dot, dot. A1, 1 over 5. A2, 1 over 5 squared. 1 over 5 cubed is 125. 1 over 5 to the 4, 625. So 1 over 5 to the power n. Yes, very good. Find the formula for, yes, so you try that. Huh? Example 3, you try. What is A1? A1 is 3 over 5. A2, 4 over 5. 5 squared. Huh? This is 5 over 5 cubed. So this is starting with 3, no? 3, 4, 5, 6, 7. So here this should be, yes, 3 plus n over 5 to the power n. Very good. Very good. 3, 3 plus n, no, 2 plus n. 2 plus n, nah? 2 plus n. What is the first term? First term 3 over 5. Second term 4 over 25. 5 over 125. 6 over 625 and 7 over 3125. Lots of terms written. 2 plus n, 2 plus n bracket, over, yes, 2 plus n bracket over 5 to the power n. Very good. So, write down a formula for an for this sequence. So here, let me say this also. 1 over 5, 1 over 25, 1 over 125. An is equal to 1 over 5 to the n. So we can write this whole thing as just 1 over 5 to the power n. 1 over 5 to the power n. Here an is equal to here 3, 4. So that is n plus 2. N plus 2. If it is 1, 2, 3, 1, 2, 3, 4, 5, then it is n. Now 3, 4, 5, 6, 7. So it should be n plus n here 1, n plus 2. N is equal to 2 plus 2. N is equal to 2 plus 3. Here 4 plus 2. 5 plus 2. Bottom is the same as the bottom of the previous one. So n plus 2 divided by 5 to the power n. For n going from 1, 2, 3. Okay. Then comes the most important thing, limit of a sequence. What is there to study in linear sequences? What is there to study in sequences? Sequences are these type of functions whose domain is the set of all positive integers. What is there to study? Once looking at the graphs, look at this sequence 2n. The graph keeps on increasing. As n gets bigger and bigger, an values are also getting bigger and bigger. Here, 1 over n example. When you look at the graph, you see that values of the sequence, they are getting closer and closer. The values are getting 1 over n. As n gets bigger and bigger, we feel that those values are getting closer and closer to 0. This one, as n, this sequence, as n goes to infinity, no matter how large you make n, it remains at 2. Here, minus 1 to the n sequence, no matter how far you move along the x-axis, it keeps on oscillating between minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. It doesn't settle. At a specific value. Keeps on oscillating between minus 1 and plus 1. So as n goes to infinity, these values are not settling to any of the numbers. So, for sequences, what is there to study is the behavior of the sequence as n goes to infinity. So that is or approaching. Yes. So what is there to study is the limiting behavior. What happens to these values ans as n goes to infinity? So that is what we are going to study tomorrow. Okay, limits of sequences. So today is just the basic introduction to the sequences. Okay. So as I told you, as by mistake, they have assigned 2 hours for online session. I'm wrong, sir. I got it now. Okay, good, good. So let us continue this study on sequences tomorrow. I will be doing the first 2 hours, and the last hour will be done by Mr. Darshana, Bandaramthinaka. Okay, so see you all tomorrow. Tomorrow. Okay, as I told you, understand, no? I'm not stopping early this was scheduled to be 1 hour, and by mistake they have scheduled it for 2 hours. So we started around. Okay. So yes, about 45 students were there today. So I'm sure that the class size is much bigger. So I only did the very basic things. So let us continue the study tomorrow. Okay, students, okay.
Recording stopped.
Can you please upload the slides to LMS? Yes, I will upload the slides to the LMS. Okay. That's why I got it recorded. Yes. Okay, students. Bye. See you all tomorrow. I
Okay.
know it's a bad time slot, but what to do, huh? Try to get it changed, but it didn't work. So, bye. Bye. Yes, you are welcome. Okay, you are welcome. Bye.